Regents Review number 17. Question number 1 shows you a cubic function, and you could solve this problem by using your TI-84, and you could type each of these multiple choices into the y equals button to see if it looks like the graph that you see here shown. So I'll try typing in this first graph y equals quantity x minus 3, and then times the quantity x minus 1, and then the third one is times the quantity, oh, you don't even need that times sign, x plus 1. And after I'm done typing in that choice, I can view the graph, and really what I'm focusing on here are where this cubic function hits the x-axis or the x-intercepts. And you'll notice I only have a single negative x-intercept, and this one here on the graph has 2. So that's one strategy. You can use your TI-84. The second strategy that you might have learned or will learn soon is that these x-intercepts, also known as zeros or roots, occur at -3, -1, and +1. And solutions, roots or zeros, are always the opposite of the factors. So if the factor is -3, then the x-intercept will be +3. So if I look at the 3 roots that I have here, if I were to write them back as factors, they would have the opposite sign. So I would need a +3 factor, I would need a +1 factor, and I would need a -1 factor. And any combination, any order, you could commute these around, would be the solution. So I'm looking for a positive x plus 3, which we have here, and we have here, and we have here. So this one is out. I also need an x plus 1, which this one has, this one does not have, this one has. And I also need an x minus 1, which results in only option number 2 having the same zeros, roots, or x-intercepts. Number 2 asks us to model a function where we are selling ice cream cones, and P of C is the profit, and C represents the number of ice cream cones. So if the number of ice cream cones you sell is the domain, then you have to think about what type of numbers those could be. So I can't sell negative ice cream cones, so I can't be less than 0, right? I can't be less than 0. And then I cannot sell partial ice cream cones, so I can't be a ratio. So that leaves us with option number 2. Question number 3 asks you to represent this situation is an inequality where x is the pounds of strawberries and y is the pounds of raspberries. So let's focus there. If x is strawberries and strawberries are $1.60 per pound, then the number 1.60 has to be with the letter x. So 1.60 has to be with the letter x. So that means that these two options wouldn't be possible. Now the next thing we notice is that these numbers are exactly the same. So really all I need to focus on are these items. Those are the only other things that are different that differentiate option 1 from option 2. So we're going to focus on the statement that says she only has 10. So she cannot spend more than 10, so she can only spend less than or all of the 10 that she has. Number 4 asks you which solution is not a possibility, so you could certainly guess and check by erasing and replacing all of the x values with the x coordinate given, and then checking to see if that would be equal to the y value. You could certainly do that mathematically. Another option for you, which might be quicker, is again to go to your TI-84 and in the y equals button, type the function that you have, which we have as x squared minus 3x plus 4. And now I'm going to go ahead and press second graph and look in that table of points. So when I look at my table of points, I see that 0, 4 is not a solution. I see that, x squared, I forgot my x. See this? X squared plus 3x plus 4. Here we go. Sorry. Now when I look at my table, I see that 0, 4 is a solution. I see that 5 and 14 are a solution. I see that -1 does not match with 6. It actually matches with 8. So it's looking like this one is not a solution, but how do I check that one? It's not in the table. So in order to check a decimal value, I simply go to the table settings in second window, and instead of starting at -1, I'm going to start at this value. I'm going to start at 1.5. And then when I view my table, I can see that 1.5 does match with 1.75. Question number 5 asks us if the domain includes these three values, then what is the range? A range is an output. So if I were to enter into this function the value -2, and then the value 3, and then the value 5, what would be the outputs? And those three outputs are what's going to determine our range. So the quickest way for us to do this is, again, to type this into our y equals button on the TI-84. So in the y equals here, I'm going to enter 2x squared minus 8, 2x squared minus 8, and I'm going to look at that table again. So in my table, I'm looking for -2, right? That's my domain value, -2. And when I arrow up, I get a -2 matches with 0. So I need a 0 in my list. So this list doesn't have a 0. This list doesn't have a 0. But these both have it. Now, what happens if my domain is 3? My input is 3, my output is 10. So I need a 10 in my list. This one does not have a 10 in the list, so I have found my answer. It's option 3. Number 6 asks us which one is not a linear function. A linear function has a constant rate of change, meaning you increase or decrease by the same amount every time. So if a gym charges a membership fee of $10 and then $10 per month, that is plus 10 every month. So that is linear. We're looking for something that is not linear. A cab company charges $2.50 initially, but then its rate is $3 per mile. Again, that's plus 3 every time. That is linear. A restaurant employee earns $12.50 every hour, per hour. $12.50 plus $12.50 plus $12.50. That's linear. And the last one here says you depreciate 15%. There we have it. Percents are exponential, not linear. Number 7 asks us to graph this system of x squared plus 4x minus 5 and gx, which is linear, x minus 1, and then it asks us to determine all the values for which f of x is equal to g of x. And that means that we are looking for the intersections. And the intersections will have x values and y values, but we're only looking for the x values. So let's see, I'm going to graph g of x in red, and I'll graph f of x in green, and g of x I can graph using my linear relationship knowledge, where I have a y-intercept of -1, and I have a slope of positive 1/1. So I don't even really need a table for this, because I know a shortcut for graphing. So I don't even need to write anything down, but I do need to extend my line in both directions. I do need to label it. And now for the other part, I'm going to get a table of points. So I'm going to turn my graphing calculator on. I'm going to go to my y equals button. I'm going to type in the function for f of x, which is x squared plus 4x minus 5. And I'm going to take a look at this table. I'm going to try and grab some points that are negative. I'm also going to grab some points that are positive. It looks like, I'm graphing this in green. It looks like -716 won't fit on my grid. So I'm going to go -6, -5, -4, -3, -2, -1, and I see that I'm starting to cycle back around, right? So I'm guessing the next one will be -5, yep, 0 and 7. This one is 0, this is 1, this is 2. All right, so using that, point, negative 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7. The next one will be negative 5, 0, negative 4, 1, 2, 3, 4, negative 5. Next one is negative 8. Then it's negative 9. And then we symmetrically come back around the other way. And we've got a point here, and then we've got a point there. So now I can connect with a smooth curve. I can label my graph, and now I can identify these points of intersection here and here that have x values of 1, 0, so 1, and this one is 1, 2, 3, 4, negative 4. So those are our two solutions for when function f of x and g of x are equal. Question number 8 asked us to graph the inequalities, so I'm going to do a little manipulation over here in my workspace. I'm first going to distribute the right-hand side, giving me 2x plus 2. I'm going to subtract 2x from both sides so that I can get all my variables together. And then I'm going to add 3 on both sides, so subtract 3 on both sides so I can get my constants together. And then when I do my final division, I actually get x is greater than negative 1/2. So I need an open circle, so these are out, and I need it to be at negative 1/2, and I need it to be moving in the greater direction. So option B. Number 9, I think I'm going to use a clearing fraction technique. I'm going to use the multiplication property of equality here. I'm going to use the number 15, and when I divide first and simplify, I'm going to get 3 times 2x. I'm going to get 5 times 1, and I'm going to get 1 times 7x minus 2. So that's done. I'm going to subtract 7x from both sides because I like my variables on the left. And let's see, I get negative x plus 5 equals negative 2. I'm going to subtract 5 on both sides. I get negative x equals negative 7. And I'm divide both sides by negative 1. And I get my final answer, x is equal to 7. You can certainly put that in your graphing calculator into the initial equation here. You could put that 7 here. You could put that 7 here, and you could see and check that these are equivalent. All right, last question. Write an expression in terms of pi. That means pi should be in your answer to represent the area of the entire basketball court. Well, this right here is a rectangle, so we're going to do length times width. But this right here is a semicircle. So I'm going to do the area of a circle, pi r squared, but I'm going to divide it in half. I could also write it like this, pi r squared with a half in the front. So either way is acceptable. Looks like I know the length and the width, so I'm going to say the length is 10, the width is 8, so that's going to be 80. I'm going to add half of pi times r squared, and the radius is half of 8. I'm going to put a 4 here, so I could write it like this. I could also start to simplify and write 1/2 of pi times 16. I could also take half of 16. This is another good answer. Half of 16 is 8. This is another good answer, so write it this way. All of these are acceptable. Full credit for this, this, or this. Now that we have an expression, we can actually find the area of the basketball court to the nearest hundredth by taking this expression, 80 plus 8 pi, and typing it into our graphing calculator. So I'm going to type 80 plus 8, and right here in blue, second exponent, I see the pi sign. And make sure you're rounding to the nearest hundredths, so that's 105.13. And let's get the dimensions. It's feet. We're talking about area, so it's feet squared. And that concludes Regents Review number 17.